In this unit, we're going to talk about human factors and human error. Here's some examples of human factors. All of these caused by some sort of human performance limitations. Here's a definition of human factors according to the FAA. It's the multidisciplinary field of human factors devoted to optimizing human performance and reducing human error. It's the applied science that studies people working together in concert with machines. Human factors include a broad spectrum of influences, such as the organization, which would be culture, personal, or people, both on and off the job, and a combination of both. All of these influences can and will affect your work performance. These would be called error-provoking conditions. Errors can be broadly categorized as non-intentional, which are more common, and intentional, which are less common. Now let's shift to how and why errors happen. Errors happen because of an intention or a plan that was not properly executed. And it could be due to a number of things. As I've already discussed with the Dirty Dozen, those 12 factors that can affect performance on the job. Those are included in some of these bullet points here, and then some other things as well. Time pressure, fatigue, poor or no procedures, poor or no policies, rule breaking, distractions, complacency, and lack of resources. Here's the Swiss cheese model. And if you're not familiar with it, it's really just a metaphor about slices of cheese, and they all have, each slice has a hole in it, or multiple holes. And if the holes line up, you have the trajectory of an accident that can occur. So what we're trying to do is make it so that these holes don't line up. And we start out over here with organizational influences, right? The organizational culture, management decisions, and then we come down here to unsafe supervision, and then preconditions for the unsafe act, and then the unsafe act itself, and then this would be the accident or incident right here. Now, the latent failures, when we talk about latent conditions or latent failures, we're talking about things that might lie hidden in the system for a long period of time, months or even years, before they wind up penetrating these holes further down in the Swiss cheese slices. So that's what these latent failures are. And then the unsafe act itself would be the active failure. These latent failures can penetrate the holes or the defenses that you have in place in the Swiss cheese slices. And as I said, it may take months or years for this to happen. You might be the trigger puller. Okay, you might be the person that commits the actual unsafe act, and I call that the trigger puller. The individual that enables the accident to happen. It's the active failure. However, it may not be the root cause of the accident. So in the old days, and then even in some other countries and cultures, this is still the case, the person responsible or people responsible for the unsafe act itself would immediately be punished without looking at further influences from the Swiss cheese model, looking at some of the organizational influences. So what you have is maybe bad management decisions that are made in the boardroom a year ago, 2 years ago. They lie dormant in the system, and then they create preconditions for unsafe acts. And then really, even though you commit the unsafe act yourself, it may not be specifically your fault. Blame should not put wholly on you, because of the fact that there could have been some upstream organizational factors that caused you to commit the error. But errors aren't always the result of upstream organizational failures. There can be one-offs or isolated events. An employee might have a better way of performing a procedure, sign off work that hasn't actually been done, show up to work impaired, not follow the rules, not use safety equipment, etc., etc., etc. It's not the same as the trigger puller, which is the enabler of an accident. Okay, so this person, where there's a one-off, could certainly be wholly responsible for the accident to have happened, although this is usually not the case. Now, we can reduce error likelihood by design, but even then, errors will still occur. Now, if you look over here to this picture of flaps and gear for the aircraft, you notice that we have a flap control lever that's shaped like a flap, and a landing gear control. It's shaped like a wheel, like a landing gear. And the reason for that is so that people don't confuse one with the other. And that has happened a number of times in the past, especially with some of the older general aviation aircraft. So we try to, reduce errors by making things, more intuitive. Now, on the other hand, if we look over here, throttle and mixture controls. So this is on an old Cessna. And this is kind of interesting because even though the throttle is colored black, the mixture control is colored red, they're very close to each other and they kind of look alike. And when I was a flight instructor, a long time ago, I told my student, okay, well, let's reduce power and let's go down to the traffic pattern and do some touch and goes. And the student that I was working with kind of absent-mindedly just grabbed the mixture control and pulled it back, thinking it was the throttle. And of course, the engine started to wind down and the prop stopped turning and the student got very nervous. But it wasn't a big deal because we just had to put the mixture control back in. But the lesson that was learned there was, even though these are color coded and one is red, that's, to grab your attention, to be careful with that. Still, it's possible that you can commit an error. And of course, that's a non-intentional error. You didn't intend to pull back on the mixture control. Errors can be broadly categorized as non-intentional, so there's no intent to commit an error, not aware that an error has been committed, and as mentioned before, you may be the trigger puller because of latent upstream failures. On the other hand, we have intentional errors, intent to commit an error, aware that an error has been committed, and this is called a violation. Here's 3 scenarios for the same error. An aircraft engineer is required to check rivets for cracks. Procedures require use of special work stand and lights. Scenario A, the engineer gets work stand and lights, checks rivets, but misses a crack. Scenario B, the engineer doesn't bother with the work stand and lights, walks under the fuselage with flashlight and misses a crack. And scenario C, the engineer goes to fetch the work stand and lights, but finds them missing or broken, walks under the fuselage with flashlight and misses a crack. So when we look at this, we want to see which one is intentional versus non-intentional. And then, of course, the punitive aspect of it would come into play. So if we look at scenario A, gets work stand and lights, checks rivets, but misses a crack. Okay, is there culpability there? Was this intentional? The answer would be no. Now in scenario B, doesn't bother with work, stand, and lights, walks under the fuselage with a flashlight and misses a crack, then that is intentional. Excuse me, intentional because the engineer didn't bother using the required equipment, the work, stand, and lights. So the same error was committed, but in scenario A, it was unintentional, whereas scenario B, it would be considered intentional. And then scenario C is an interesting one. Once again, it's the same error, but here we have a problem with, let's say, a lack of resources. So the engineer wants to use the work, stand, and lights, but finds them missing or broken, but then continues to do the task and misses the crack. So we could say, and this could go both ways, we could say, well, the engineer shouldn't have done the work without the proper equipment, so possibly we could say that that one is intentional. But on the other hand, we could also look at that and say, well, maybe this is an organizational problem because the work stands and lights were missing or broken. So if this is a resource problem and management doesn't want to get the proper equipment and engineers are doing this work without having the right equipment, that creates a potential problem. So in this case, you know, the same error occurs. There's a crack that was missed by the engineer. So it's an interesting one on scenario C, something to think about. But that's kind of that's the way it works with this. So it's the same error, and it's all about intent. Just remember, it's about intent. Now here's an example, a personal example I'm going to give you of a non-intentional error. I used to fly Learjets, and we would transfer fuel, you know, in flight for various reasons. Occasionally you'd have a fuel imbalance. And here's the fuel control panel on a Lear 35. And to transfer fuel, if you want to transfer from the left wing to the right wing, let's say, we do two things. We open the cross-flow valve, and then we turn on the corresponding standby pump, which would be right here, the left standby pump. So by doing that, we're transferring fuel from the left tank or the left wing to the right wing. Well, the transfer rate is about 50 pounds per minute. And it could take, depending on how much fuel you had to transfer, it could take a while. It could take 5 minutes, 6 minutes, whatever the case may be. The problem is that if you get distracted or you just forget about it with that because you don't give yourself a reminder, this won't automatically shut off. So if you forget that the fuel is cross-flowing, it'll just continue to do that until you have a really bad imbalance going the opposite side. And then you have to go through the process again, opposite, to get the fuel to balance up to put it all back in the left wing. So it was always one of those things where you had to be careful that you had to remember that you're transferring fuel. Give yourself some sort of a reminder, you know, and put your hand on the standby pump switch, or take the checklist and put it on the throttle quadrant or something, or whatever. So that would be a great example of a non-intentional error. Because remember what I said in one of the previous modules when we talked about memory, prospective memory, remembering to do something in the future, like saying I'll shut off the cross-flow valve in a couple of minutes. We're not very good at remembering things in the future to do unless we have a salient cue or a reminder. So that's very important to keep in mind. Now here's an intentional error. This wasn't me, by the way. This occurred in a mountainous airport in the snow. And the pilots exceeded tailwind operating limitations. They did not conduct a go-around when the approach became unstabilized. Of course, there's a lot more to the story than this, but the fact is that they intentionally tried to land this aircraft in conditions that were just not within the, let's say, aircraft operating limitations or the pilot limitations, because of the fact that they exceeded limitations such as the tailwind operating limitation, which is 10 knots, and also they should have gone around with an unstable approach rather than tried to land. So that would be an example of an intentional error, or errors plural, because of course there's always multiple links in the chain. So those are a couple of examples of non-intentional versus intentional errors. Thank you.